Now in this problem here, our last problem, we want to know how much money should we deposit. All right, that's the present value. Now what we do is we want 10% interest compounded quarterly, but we want to make $67,402 in 10 years. So because we're given an interest here, I'm going to write this formula as this. I know that the interest is equal to the future value minus the present value. But now I know the interest and I know the present value. That's what I'm looking for, present value. I don't have any future value here at all, but I do know a formula for the future value. So I'm going to rewrite this. You know, our formula is this. Let's just say what that is. Our formula for future value is present value times 1 plus r over m to the mt. So what I'm going to do here is I'm going to rewrite this to look like this. I is equal to FV, but FV is this, so it's going to be PV 1 plus R over M to the MT, and then minus, there's the minus coming here, minus PV. We try that again, minus PV. So we had to do this because we don't have any future value. There's nothing in this problem that deals with future value. But there is something that deals with present value, right? How much do we have to deposit now? So that's the present value. So I have a formula that relates future value and present value right here. So I'll take FV and replace it with this expression right here. So we'll get I equals FV, but that's this big expression, minus PV right here. Now I'm going to carry this one a little bit further. I see I've got this term minus this term, and both terms have a PV in it. So I'm going to rewrite this by factoring that PV out, and I'm going to write that as I equals PV, and then when I factor that out, I'm going to have this. I'm going to have the 1 plus R over M to the MT, and then a minus 1. Does that make sense? If I take the PV out, right, take the PV out, what's left? Well, if I take the PV out of here, this is what's left right here. Take the PV out of this term, and what's left is this one. And then, if I take the PV out of this term, what's left is a 1. So really, you kind of have to see it. There's a 1 times that. And then what I'm looking for is PV, right? We're looking for PV. So I can get PV if I just make this division here. So here's what we're going to have. I can either write this formula here and then start substituting, or I can simplify this formula down to this. That's what I'm going to do. So I'm going to get this. I'm going to get that PV is equal to I over all of this. So I probably don't need that square bracket down there. So it's going to be over 1 plus R over M to the MT minus 1. So this is the formula that I think we're going to be using as the most convenient form. So let's see, let's start putting our numbers in. So we're just going to get PV is equal to I. Now I, that's the 67,402 over 1 plus R. Now this was at, what do we have here? 10%, so 0.10. And we're going to compound quarterly. So raised to the 4 times, and we're doing this for 10 years, and then a minus 1. So on my calculator, I'm going to put in 67,402 divide by, now open a parentheses for the denominator. You know, the denominator is an operation in it, so I'm going to close it in parentheses. So this parentheses right here is really opening up the denominator. Then I have this parentheses, so we'll put that one right here. So it's going to be quantity 1 plus 0.10 over 4, close, raise that to the, now 4 times 10, I've got an operation in there. You can either write it as 40, or if you want to multiply it, it's 4 times 10, close, and then you got a minus 1, but now you have to close the denominator. So I'm going to close that off. Let's just count these up. So this parentheses here starts the denominator, and that one ends it. This parentheses right here is actually, that set of parentheses is this one. This one here is here. This one here is here. And then this parentheses starts the exponent, and this one ends the exponent. So these two go together. And I'll do this up here. When I did that computation, I got that the present value is equal to 39999.67, right? But 399, that's $39,996.67. That is essentially a present value of $40,000.